Thank you so much for joining this channel again. So we are in a video 2 of the banking KYC agent preparation. So again, I will reiterate before visiting this banking KYC video 1 and video 2 that we are doing right now. Please go through this playlist, Agentic AI Mastery, which will give you all the concept of single agent, multi-agent, tooling, supervisor pattern, how to use routing, how to use MCP, what is the meaning of observability, and the structure output, everything, all the concepts. So whatever concept you will learn from the day 1 to day 18, that you can use for building up the agent. So for me right now, I am creating the agent KYC agent, banking KYC. So please go through the video 1. So these slides are part of the video 1. These all slides, part 1, part 2, part 3, part 4, and part 5. So now we are in a video 2 where we will discuss part 6 to part 8. So in the part 1 to part 5, we actually created a API solution or API endpoint which will take the input for uploading the document, and then the API will return in JSON format the candidate is approved or not for with the KYC. Right. So there is normal architecture we have used, like clean architecture, layer architecture, anything you can take it. But for 6 to 8, we have taken an event-driven architecture. There is API call, but it's an event-driven architecture. And so producer will make API call and drop the message. A subscriber will listen to the topic. Subscriber maybe Windows service or Windows scheduler, which will pull the topic and listen to the data sent by the producer. The reason for this is that in KYC, you know that if the bank is big, you will get a huge number of requests. So API endpoint may not handle all the loads. So there is another approach. You can take event-driven architecture. So any of them you can use. You can combine all the that features that we discussed in the part 1 to part 8. You can take all, or you can take some of them, but you can build your own agent using this concept. So let's start with the part 6, part 7, and part 8. And for doing this, we need to local Docker application in our local. Docker also is a container which will hold the application. We have a Confluent Kafka which will hold the data, which will be like used by the pub and publisher and subscriber. And we will show you how to set up the Docker also, Confluent Kafka, and then we will execute 6 and 7 and 8 all. So what is part 6? So part 6, as I said, part 1 to part 5, we are doing the API development where where the user is uploading the document, and it then going to this that supervisor. Supervisor is actually calling the router. Router is sending the request to the LLM to decide which agent to be called based on the input, whatever the LLM is responding, and based on that they will select the agents. Then agent will be executed through the supervisor pattern, and agent, if required, call the tools, which the tools will give you the information. We have some web intelligence tool, identity tool, rigs tool. So those two tool will help the LLM to take a proper decision, and once the data will come up, then it will be sent back. So now it may happen that you have a huge number of requests. So requests may fail, requests may unprocess. In that case, it will be difficult. So that's the reason there is another approach. If the data peak load is high, you can go with the event-driven architecture, where publisher will publish the message and subscriber will read the message as per the convenience when it will work. So till day 5, we have done API supervisor agent. Now it is API will call the event or publisher, then router, same thing will be happen. But once the message dropped by the publisher, the subscriber will read the message, and once it read the message, then the AI router agents and all the things will work as it is that we have done earlier in the day 1 to day 5. So it is scalable, event based, and streaming also. So Kafka right now in local Kafka we are using. .NET is a local, Swagger also local, we are using Swagger, right? And Kafka is it and Docker. So once you run the Docker, Kafka will be automatically start running. We will show the demo also. So this is part 6, pure event driven message. So now you can see the same thing. User will hit the API, then the Kafka producer will drop the message to the Kafka topic, then Kafka consumer will read that, and then the remaining flow is as it is that we have done in the part 1 to part 5. Supervisor agent execute, result printed, producer and consumer. So it is a pub sub concept is there. So this is the overall architecture. How? So client will drop the message. We have a KYC API controller that we already created. So KYC earlier in the part 1 to part 5, they are calling right supervisor agent or KYC and identity agent. Here the Kafka producer will be called. Kafka producer will drop the message to the KYC and hyphen request topic, and the topic will be listened by a service, background service, that is a Kafka consumer. Kafka will read the message, and then the remaining flow as it is same. Supervisor, orchestrator, identity agent, fraud agent, risk agent, web intelligence agent, all will be will talk to the tools also, and then it will be sent to the Azure Foundry OpenAI, which will give you the final decision, and it will come back with approved or not. So this is the whole architecture for event-driven AI. So browser, I know how we will run. The browser will run, then with the local API will start. Kafka producer will drop the message, and I will show you how that message will come into this Kafka topic using the Docker. Then the Kafka consumer will run. Kafka consumer will pick up the data, and the remaining flow is supervisor to a router to a selection of agents, followed by the tools, and then get the data from the Ulama. So these are the comments. We will show the comments in a separate section. We will execute the setup. So these are the comments that are required actually to prepare this environment for part 6 to part 8. So part 7. So whatever we have done in the part 6, it is like a top up on the part 6. So say for example you are dropping the message as a producer, but the consumer failed to pick up the message, or maybe there is a exception came from the third party, so there will be a retry mechanism, so some pattern has been used. It may happen that the data is not processed multiple times. In that case, we will take into the another queue, data later queue, which will be taken care separately for processing the data. We will show that in case the data already processed, again you are trying to process the same data, so the duplicity may come. So idempotency also will check. So these are the things required actually to for a stable application. So in real time failures are expected, right? We cannot, even though you do a number of architecture or to do the stable design, we need some mechanism to manage this failure, poison queue and the duplicity, right? So we will show that in the demo. So Apache Kafka consumer, then try, the success means done, but it is a failure, then retry, max try, and then later queues. Just like we have a normal queue, we are dropping the message in the KYC request topic, but in case the data is not processed, then the message will go to the date later queue, DLQ, KYC-DLQ, and this is KYC-request. And the last one is nothing but whatever we have done in the day 6, sorry, part 6, part 7 in the, and it should be part actually. Then additionally we are adding the logger, observables, and the that other things like LLM tracking, how much time it is taking, safe decision, good prompting, Docker full system packaging. So these things are that without that the things will not complete. Logging, monitoring, runtime, reliability, and safety guard. So we will go to the demo, and before that, first demo we will give you for the Docker and this Kafka setup, and then we will go for the 678 application demo. Local, and then how to run the Kafka inside this Docker container. Okay. So now you can see that the Docker is running, and we'll go to the PowerShell. You can go to the bash also, but PowerShell I am just using. Then you will take this project path. So we are inside the project path. Then we will run this Docker compose. So now it is creating. See, you can see that .NET Zookeeper Kafka all being created. The reason is this docker compose.yml file has been added into the project. This is the main file. So you have to add this file, and then you have to run the docker with that command. Then docker will run this Kafka automatically. What is next? Next, we can check this command whether the image has been created or not. So you can see the image has been created 41 seconds ago. Kafka, Zookeeper, these two. So what is Kafka, what is Zookeeper? You can take a separate session for that. But as of now, you just remember Kafka is a message broker, enterprise message broker. So now this has been done. Now we will create, now we are inside this container. Then we will create the Kafka topic. So you have to execute the first command. So we are inside the machine. And then we will run this command, not this command. Forget about this command, because we are inside the docker, and we are creating the Kafka topic. So this is the topic name, as I said, and the ppt KYC underscore request. It will run on the localhost 9092. See, the created topic is KYC and hyphen request. So now it is created. Now we will listen to the queue whether any data is coming or not. It will start beginning. So right now there is no data. So for that we have to run the publisher. So what we will do? So as I said, there are two part, public consumer and the producer. Consumer is nothing but a service, background service, and producer is the API endpoint. This will be called from the this Kafka controller. Controller will call this producer. Producer will drop the message to the topic. How it will drop the message to the topic? It will go inside, and we have this code. So you can see the same name that we have created, KYC underscore request, created topic, KYC underscore request. So data will come over here. The moment data will come over here, then we will run this consumer service as a background service. It will pick up the data. What it will do, it will listen to this localhost 9092 group ID we have taken, and then it will read this, it will subscribe to the KYC underscore request. It will read the data, and once they read the data, then the supervisor will come into the picture, and the rest of the things are as it is same. Supervisor, router agent, picking up the worker agent, talking to tools, getting the data, and finally the response. So see how it is working. So now we will run the producer first. So for producer, we are stopping this background service only producer. So let me run it. So now you can see in the topic nothing, is only beginning. Right now no data has came. So now we'll go over here and we'll put, suppose John, and this is, suppose the document is uploaded, right? PAN card, right? Something like that. This is the document. The moment it will click over here, see, it will go into this producer. It will connect to this localhost 9092. This is the topic that we already created and did a message. Now we'll see that the message has been dropped or not. See, the John AIOPG 4999F, the message has came. So what we will do now, we'll stop over here, and now we'll run the background service. What we will do for that, we have to enable that because it will listen to the message, so we do not need this. So let's run it. So now see, this came over here, the topic is this. So ideally the same data should come from that topic. See the data, it is reading KYC and the data is John AIOPG 499F. Now it will do the same thing. Go to the supervisor, go inside, same call that we have done in the part 1 to part 5. It will take the decision based on the API model. API model return the data that we already done in the part 5. So there is a data is already there that we have shown that how we can check it, so we can run again the topic is there or not. Okay, so the data is okay, so let me run it one more time. Just putting aim one, you understand there's a difference of data. So data has been submitted, we can see over here data has came. Now we'll stop it and run it as a Windows service. So for that we'll enable it. So we'll check the data has came. So you can say aim11 at came. Now it will call inside the Olama. No, sorry, it is OpenAI here. So now it will do all the checks and balances. So on this point, I don't know what will happen, but this has already been discussed in the part 5. However, we are executing that. So now the wave fail actually came. That's fine. So rejected, adverse media has been rejected. That is the final output. So this is the part 6. and let's improve it with the part 7 that we discussed already. So let's stop it. We have to copy this code also. Part 6 complete. Now we'll go to the part 7. So part 7, as I discussed, we are implementing idempotency, retry logic. So everything is same. Only the difference is when the consumer comes into the picture. So consumer will have some logic. What is the logic? This is the extra logic we have added. First of all, we have checked the data already processed or not. That is idempotency check. For idempotency check, we have a file idempotency. Let me check idempotency. Yeah, process to. This processed or not. If we will not duplicity, we will check, right? That we discuss here in this retry, date later, and idempotency. So idempotency will be checked. Next, what we'll do? We'll check the retry. So suppose you are trying 2-3 times to read that, okay, and it get fails. So again, it will try 3 times. After 3 times also, if it is retry failed, then finally it is go to the date later queue. So what is date later queue? Similar to the request queue, but date later queue means we'll only hold the data which is not processed yet. So this is date later queue, and this is the same thing. We will drop the message over here, the date later queue. Then only it will be picked up again, right? Otherwise, it will be remain in the same position. So date later queue. So how it will be executed? So the data already we have this data. So what we will do? What we have done actually over here to make it fail, we have just thrown a exception kind of thing so that you understand okay, why, or not a, suppose exception or something down, then it will be retried, right? And if the 3 retries are failed, then only it will go to the date later queue. So now assuming that we are starting from again, so controller is already work is done from the previous day 6. This is the same topic we are using in the day 7 also. So we'll run the directly the uh, consumer. So for that service, so let's see, we run it. So now the same thing, same code, same data. Actually taken the old one. That's fine. We haven't rerun the application, so that's fine. It has taken the data. That's also fine. Now this up to this code is same like the part 6. Now on the main thing is that it is processed or not. So that will be checked. So in the real time, we will check with the using the correlation ID and topic ID. Here we are just checking it is processed or not with the boolean. It is not processed, so it will call to the same supervisor agent and everything, but inside the retry mechanism up to 3. So what we will do? We will first try this. We will go inside. Similarly, there is no difference from the previous one, but somehow we have to make it fail, otherwise it will not go for the retry, assuming the server is down and everything. So all are fine. In the fraud check, we are throwing an exception. The moment we will throw the exception, again it will try, again it will try. Again exception, again it will try till the count is 3. That is the retry mechanism. In API calls, right? Whenever we do a third-party API call, we do the retry mechanism. So 3 times done. Now the data should go to the date later queue. But do you have the date later queue? That we need to check. So for that, what we have to do? We have to create a date later queue topic. So for that, we'll take the same code and we'll check the name of the queue. You'll see the same way we will create this. Where to go? Okay. See, the topic has been created. So we have to do the same thing for the checking, right? The data has came or not as a data later queue. So for that, we'll put the name of this. And it will poll. And now we'll go to the code and we'll see all the retry count has finished. Now so it's unsuccessful. Now we have to send to the queue. The reason is this data queue will be listened by another poison queue monitor or something which will pick up this unprocessed data. because in Kafka the data don't go automatically to the poison queue. See, the data has came to the data letter queue, and also we have sent it the data to the data queue. So hope you understand what is the part 6 and how we have improved the part 6 with the part 7 to make it more reliable in terms of retry mechanism, idempotency, duplicate checking, and the the data letter queue. So now let's move to the last one, that is part 8. So in the part 8, as we discuss, that we are whatever we have done in the part 6 and 7, that will be guarded by this, that how much time it is taking. So you can say observability that we have done in the day 14 also, if you see into the in the top. So we have done observability in the day 14. So the same thing we are using over here. So LLM use, we will use the logging and everything. Okay, so let's see what is in the code. There is no much difference. So the difference is, like if we go to supervisor agent, we have added a logger file. This logger we are using normal logger, but in future we have a plan to use ELK app insights, okay, open telemetry for better logging. But console log, just to give an idea what is the logging. So that is injected as a dependency injection over here, and we are logging the that supervisor, and then we are logging the router is finished or not. So and then we are checking the identity. So wherever required, you can do this this logger you can use. And also in the router agent we are using the timer, which will help you to understand how much time it is taking by this kernel, and then it will give you that the millisecond. So that is, so another thing you can do, that prompt upgradation. So just like this is not there in the rules, so we have added the rules also to make it more fine-tuned prompt for taking giving to the ulama. So in the day 8, we try targeted this upgrading this part, adding the hours, that timings, okay, stopwatch and the logger. So this will make more sophisticated. So safe AI decision to be made based on the prompt we have given. Failure handling we already done, but that is also being shown. LLM timing and everything. So this is the part. So Kafka, in the part 7 we have done this consumer retry and observable, safe, deployable. So logging and tracing already shown, guardrail you can use, and Docker full system. We can use the Docker also, but right now I'm not showing over here. We will take it as a different video. So hope you understand that in the part 8, part 1 to part 8, what has been done. So this is the whole part. Just remember this slide. This is important, that we have done an API development using part 1 to part 5, where we have tried to use the basic agentic system, then to tooling, then we have used that Azure OpenAI for making decisions, and then we are using the pattern like supervisor and the router for intelligent decision making, along with the LLM. And when the loads are high, we can take another approach, that is event driven architecture, where pub sub mechanism is there. Pub will drop the message and sub will subscribe will pick up the message. We have used that Kafka with the Docker. So how to install Docker, how to run the command that we already shown. If you want a set of Docker command separately, I can give you in the chat section. You can ask me. So this Docker and the Confluent Kafka we have shown in the part 6, part 7, and part 8 is like a ornaments on the top of the 6, 7. So